Welcome to this practical guide. Today, we're taking SSL decryption out of the theory books and straight into production in this explainer. Let's set the stage right off the bat, okay? Integrating your firewall with your PKI, your public key infrastructure, is absolutely critical. I mean, it's make or break. If you get it right, it's completely transparent. Users won't even know it's there. But if you get it wrong, yeah, literally nothing works.
To keep us on track, here's our roadmap. We'll hit the role of PKI, CAs and secure distribution, forward trust versus untrust, certificate validation, decryption best practices, and wrap up with troubleshooting and diagnostics. For all you IT pros watching, rest assured, this visual analysis right here is your exact roadmap to production-ready decryption in the next 10 minutes.
Starting with Section 1, the role of PKI. Let's transition right into the very foundation of secure communication. For your firewall to actually inspect SSL traffic, it has to sit right in the middle of the connection. And to do that without causing a massive network panic, it absolutely must be completely trusted by the client device.
Okay, let's dive into this, because this is honestly the ultimate best practice for corporate environments. What we're talking about here is a subordinate CA. That's a certificate authority derived directly from your corporate root CA. Since your endpoint devices already trust your corporate root CA, they're going to automatically trust this subordinate firewall CA too. The end result? No scary browser alerts, no broken experiences, just a perfectly transparent deployment.
Now pay attention to this, because it's our golden rule. You need exactly one subordinate CA per firewall or proxy. Just one. Why? Well, imagine a certificate gets compromised or something goes sideways. You want to be able to easily revoke that single certificate without having to scramble and touch dozens of other firewalls across your entire network. So keep it to one.
Moving on to Section 2, CAs and secure distribution. Now that we know what kind of certificate we actually need, let's figure out exactly how we equip our invisible security guard, the firewall, with the right credentials.
Here is the completely foolproof sequence you need to follow. First, you generate a certificate signing request, or CSR, directly on the firewall. Second, send that over to your corporate PKI. Third, generate the subordinate certificate. And fourth, import it right back to the firewall. Listen, the absolute most crucial point here is this. By following these exact steps, the private key never, ever leaves the firewall. That is how you guarantee maximum security.
Of course, for the whole shebang to work, your client machines have to trust that root CA. We usually push this out using standard distribution tools, things like Active Directory, MDM platforms like AirWatch or Jamf, SCCM, or Global Protect. But hey, here is a battle-tested warning for you. Certain applications like Firefox, Java, and Python, yeah, they use their own custom key stores. They absolutely do not care about the standard OS repository. You have to manually document and push certificates to those specific apps, or for sure they are going to break.
All right, Section 3, forward trust versus untrust. Let's move into policy creation and look at exactly how the firewall handles that critical fork in the road between a legitimate site and a suspicious one.
You're going to configure two distinct certificates on your firewall. First up is the forward trust certificate. You use this for legitimate sites, like Office 365 or Gmail. The firewall uses it to safely imitate the server, so it doesn't generate any alerts for the user. But on the flip side, we have the forward untrust certificate. We deploy this one for suspicious or invalid sites. And here's the kicker. It is specifically designed to generate a huge glaring browser alert. You absolutely do not want this installed as trusted on client machines, because its entire job is to force the user to stop immediately.
On to Section 4, certificate validation. While firewalls already come with a default list of trusted CAs right out of the box, we still need a way to validate if a specific site's certificate is actually still trustworthy right now, in real time.
So there are two main ways to check for revoked certificates, CRL and OCSP. A CRL, or Certificate Revocation List, is exactly what it sounds like. It's a manually downloaded list of revoked certificates. Kind of clunky. But OCSP, the Online Certificate Status Protocol, that's a real-time query. OCSP is way faster and far more efficient for the client, because the exact moment a server sends a certificate, the client pings OCSP and instantly gets a valid, revoked, or unknown response.
Section 5, decryption best practices. Let's transition into the optimization phase. This is where we separate the basic textbook knowledge from true advanced real-world mastery.
There is one primary absolute golden rule you need to memorize for operations: decrypt everything except the necessary. Seriously, you want total visibility, but practically speaking, you just can't decrypt everything.
This is where tools like server name indication or SNI, which identifies traffic before decryption, and decryption exclusion lists become absolutely essential. You have to use them to bypass traffic that will simply break if you try to inspect it.
Speaking of things breaking, don't panic. We've all had those frantic help desk tickets, right? It is completely normal for certain applications to fail when inspected. Here's a little cheat sheet on exactly why. Take IoT devices. They frequently throw decryption failures because of really rigid programming. The solution? Segment the network. Just keep them isolated. Then you've got mobile apps, which love to use certificate pinning. That means they flat out refuse to trust anything except their own hard-coded certificate. You just have to exclude those from decryption. And corporate apps with super strict validation requirements? Just ensure your PKI setup is perfect. Ultimately, network segmentation really is your best friend here.
Which brings us to our final part, Section 6, Troubleshooting and Diagnostics. Look, even with the absolute best setup, a user is inevitably going to complain that some app isn't working. It's stressful, I know. So let's look at the exact diagnostic tools you need when that complaint rolls in.
Think of this as my masterclass checklist just for you. When things break, here's the secret sauce. Pull up your decryption logs, the application command center, and your packet captures. What are you looking for? You want to analyze the client and server hello packets. Check the SNI and look closely at the cipher suite being used. Keep a really close eye out for things like MTLS, certificate pinning, unsupported ciphers, or incomplete certificate chains. Those are almost always your usual culprits.
Now, if you're really hitting a wall, I've got a highly specific CLI command for you to run. Show system setting SSL Decrypt Exclude cache. See, the firewall actually maintains a hidden cache of decryption failures. Running this command tells you exactly what traffic the firewall is actively bypassing because of previous errors. It's a total lifesaver.
And right before you finalize your deployment, you've got to run a BPA, a best practice assessment. Think of this tool as your ultimate sanity check before going live in the wild. It takes your exact setup, compares it against industry standards, spots any configuration flaws, and just makes sure your overall security posture is as robust as it can possibly be.
So, I want to pause for just a second. Put yourself in the shoes of a network engineer on a random Tuesday. What do you actually do when a critical site breaks because of decryption?
You essentially face a binary choice here. Option 1, you permit the traffic without decrypting it, meaning you create a no decrypt rule, or maybe add it to a specific URL category. Or Option 2, you block it entirely by adding it to a blacklist. You have to make a conscious choice. Oh, and a quick warning on this, try to avoid relying too heavily on captive portals to warn your users. Generating those warning pages for every single encrypted session chews through your CPU resources like crazy.
So we've covered the whole roadmap. You now know how to integrate PKI, distribute your certificates, and decrypt traffic without breaking the user experience. But think about this. In a modern network where practically every single device is a potential blind spot, what encrypted threat is slipping past your firewall right now, simply because you are too afraid to inspect it? It's time to get that visibility. Thanks for joining me for this explainer, and I'll see you in the next one.